In this segment, we'll finish up with Assemblies V2, covering the Process Orders class, and we'll talk more about deep versus shallow copies. Now let's take a look at the changes to this main Process Orders class in version 2, which has an interesting subclass declaration and also 2 new methods down further. So right at the top of Process Orders, we declare a class Catalog that extends a tree map of string and component. And it does nothing more than that. The class body is empty. Why would you do that? Well, because it was tiresome to keep repeating the declaration tree map string component throughout the code every time I wanted to pass the catalog of components. Remember, that's how we store the catalog, is a tree map of string names and components. So this declaration allows the use of catalog instead. You can see it here. I return it from get catalog and make a new catalog and so forth. Now, Java lacks a user type definition syntax like C's typedef, but you may declare an empty body subclass that extends a complex generified type and then use the subclass instead. It's a small but sometimes helpful OO trick to add to your design repertoire. Now, get inventory, one of the new methods, reads inventory lots from a file, 1 line per inventory lot. It's pretty straightforward, and it uses the add inventory lot method that we went over in the prior segment. So there's nothing much new here. Be sure you read it and understand it, that's all. The next method, process order, by contrast, offers some deep design lessons. It fills an order by finding the component needed by the order in the catalog, right there as to make, duplicating the component by calling dupe on it, and then calling fill order on the duplicate, not on the original component, and then setting the duplicated component into the order via setComp. Now recall, by the way, that an order is always for just one component, which component may be a part or an assembly. Now, to understand the need to duplicate the component, we first have to understand component.fillOrder, which is a new method we've added in version 2. Filling an order requires drawing parts for the order from the inventory, and that includes determining from which inventory lot each part will come. This lets us update the inventory and determine the cost of the order, since part cost is determined by the inventory lot. Now, both part and assembly override fill order. There, and then in assembly as well, right there. Parts version of fill order assumes the order needs just one copy of the part, and thus makes just one call of use part. This is true if the order is only for that part. However, if the order is for an assembly, then filling it may require multiple calls of part.fillOrder, once for each time a single part is used. But this will be assembly fill order's job to do, to call many times if the part is used several times. So part.fillOrder simply fills an order by calling use part to choose an inventory lot from which to draw one part of its type, and then it saves in member source the inventory lot that was used to fill the order. And then, note, it uses source to determine the cost of the part in getCost. So that's fine if we're ordering an individual part. But what happens if the order is for an assembly? Trace the code for fill order and getCost in assembly. How do those methods work? Coming back from pause where I hope you read through those carefully. The getCost, first of all, simply adds all the costs of its subcomponents, like getWeight does, if you recall from an earlier segment. So those two are very similar. And thus this recursively totals the cost of all leaf subcomponents, of all parts. Now, fill order does a recursive fill order call on all its subcomponents, which ultimately results in a call of fill order for each part. So a fill order call makes all the leaves, all the parts of the tree of components, draw one part from the inventory and record the inventory lot from which they drew, so that the get cost will know the part cost. And then get cost at the assembly level just gathers all the costs of the parts and returns it as the aggregate cost of the entire assembly. Now that explains the fill order call. But did we duplicate the catalog component to make instead of just calling fill order on the catalog component itself? So question 2. What might go wrong if we did do the fill order call directly on to make from the catalog? Describe a something like that. In other words, describe a situation that would be a problem, a specific situation that would be a problem if we did the code this way. And the answer there is if we have a pair of orders or more, if we have 2 orders or more for the same component, then the second order will wipe out all the source values that were set up by the first order's fill order call. So we have to duplicate the catalog component in order for each order to have its own source values. Which then obviously leads to the question, how do we duplicate a component? By the way, just as a quick reality check here, why couldn't I simply have written copy equals to make like that, to a direct assignment? And after a pause there, it should be obvious from earlier discussion that copy equals to make is a shallow copy. And that would result in both copy and to make pointing to the same thing. It would copy only the reference across, and they both point to the same component. So instead, component supplies a dupe method. Let's back and look at component. And this method does a deep copy of the component. So let's see how that works. Now I'll do the easy part. In part, right here, the dupe method simply creates and returns a new part that is a duplicate of the context object. And by the way, I won't irritate you by asking why we didn't just write return this. Obviously, once again, that would be a shallow copy and not really a duplicate. So now please read and understand the dupe method in assembly right here. And I'm going to ask a kind of interesting question here. I'm going to post 2 alternative versions in comments right underneath this. And I'd like you to explain why each one would be wrong. So after thinking those through, an assembly object is kind of complicated. And let's take a look at the diagram here, and I'll show you what I mean by that. The assembly object itself, the thing pointed to by, say, to make, in turn points to a list right here, and that list in turn contains references pointing to the subcomponents. Now, both the list and the subcomponents must be deep copied. The first simplification that I had there fails to copy anything except the object itself. And the second simplification at least copies the list deeply, but does not copy the subcomponents. All it does is copy references across. Let me show you in diagram form what those 2 would do. The first bad copy would copy just the object, and the reference to the list would be the same as in the original, so we'd have like a 1/3 deep copy, I suppose you might say. The second bad copy over here would copy at least the list, have its own copy of the list, but then the list's references would point to the original subcomponents, and these guys would not be deep copied. So all three levels are necessary for this to work. And the general lesson is that a method to deep copy an object like an assembly with several levels of references from here to here to here must be sure to deep copy each of the levels. Okay, well then here's a question for you. Why didn't we deep copy the string object pointed to by name? Will the original and the duplicate end up pointing to the same string object even in the correct copy? The answer is yeah, they will. And to see why that's not a problem, first answer the following question here. Go to the string javadoc and see if you can find a method that modifies the contents of an existing string object. Note that doesn't include methods like substring that return a new string object derived from the existing one without changing the original. The question I'm asking here is for methods that are such that if I created a string, say S1, called the method on S1, then S1's content itself would be changed by the call. And then returning from a pause, I have to confess it's a bit of a trick question because there really are no methods that do this. All the ones down here, even those that create new strings, in fact, do not modify the original string. Once a string object is created, its contents cannot be changed. And a class like that is termed immutable. String is such a class, as are all the wrapper classes like integer, as well as some others. For an immutable object, a shallow copy is fine, because each reference to the copy can regard the object as its own without conflict, since none of them can change the object. So the notion of immutable classes spans many object-oriented languages, as does the principle that you only need one copy of an immutable object.